Welcome all to the video on Supernode analysis. Let us see the outline of today's video. In this video, we are going to see what is Supernode analysis and problems based on Supernode analysis. Let us see what is Supernode analysis. First, let me clear what is node analysis. Node analysis is a technique which is used to find voltage across various elements of a circuit. Node analysis is preferred when the circuit is excited by current source and the voltage across various elements is unknown. Now what happens when the circuit is excited by both voltage source and current source? So consider the circuit here. Here I have two current source and one voltage source. So based on my theory of node analysis, how am I going to use node analysis for such circuits? So that is where we use supernode analysis. It is a technique which is used when a circuit is excited by both voltage and current source. Now what do we do here? We simply consider the voltage source across these two nodes as short circuited. I assume this to be as current flowing through it. I can name it anything, I1, I2. Something I can name it. I am just going to consider this particular voltage source to be short circuited, and these two nodes can be considered as a single node as well. And in supernode analysis we use both KVL and KCL equations to solve it. So now that we are familiar with what is supernode analysis, let us see a problem based on supernode analysis. So the problem is to find voltage across the 40 ohm resistor and the power supplied by 5 amp source using node analysis for the given circuit. Here, if I consider this particular circuit here, I can see two current source and two voltage source. So definitely I am going to use supernode analysis for this particular circuit. So the very first step which I am going to do towards a solution of this problem is to find node voltage. So here I have a node V1, here I have a node V2, here I have a node V3 and a reference node. So these three nodes are the principal node. So for this circuit I have three principal node and a reference node. Since I have three principal node, we will be forming 3 cross 3 matrix for this particular circuit. Now that we have found the nodes, what is the very next step which we are going to do? Here we have two voltage source. What are we going to do for this? Let us start with the 100 volt. I am going to consider this particular voltage as short circuited, and instead I am going to write a current source here. Consider a current source here. Since this is connected to node 1, I am going to name it as IS1, and for this 60 volt already I have named a current source after node 1, so I am going to name it after node 2. So I am going to consider this as IS2. Now this 100 volt, the positive terminal is towards my left hand side. So the flow is also towards my left hand side, or I can say simply the flow is towards node 1. And similarly this 60 volt, the positive terminal is towards my right hand side, or simply say it as towards my node 2. So I am going to put an arrow towards node 2. So this is the flow of direction of the current. Here we can see the nodes are plotted and the direction of current is assumed. So now that we are clear about this, the next step what we are going to do is, since we have two voltage values given in the problem, we are going to use this particular voltage somehow for the solution. So I am going to consider this particular 100 volt. The positive terminal is towards V1, so plus V1. This negative terminal is towards V3, so minus 3 V3 equal to 100 volt. I am going to form two equations using this two voltage, since I am not going to consider this voltage source in my matrix. So here this is the two equations. Similar to 100 volt. For 60 volt, the positive terminal is towards V2. So plus V2 minus V1 is equal to 60 volt. So now we have two equations. We are going to use them to get the solution. So moving on to the next step, that is matrix formation. So here I have the circuit for reference. Since we have 3 nodes, we are going to have 3 cross 3 matrix. So here we follow the Ohm's law, that is I equal to V by R. For the matrix formation, this is my I matrix, this is my V matrix. Now what happened to my R, that is 1 by R. So instead of 1 by R, we have G matrix. So 1 by R is nothing but conductance. The reciprocal of reactance or the reciprocal of resistance is nothing but conductance. So 1 by R, that is the reciprocal of resistance, is nothing but conductance G. So that is why we have used G matrix here. So now with this we move on to the matrix elements G11. So since this is conductance, again in the circuit we have only resistance. So we are going to use the reciprocal to find the elements. So G11 is nothing but the resistance connected with node 1, which is 25. So 1 by 25 is 0.04. Same way G22, resistance connected with node 2, which is 20. 1 by 20 is 0.05. G33, resistance connected with node 3, which is 40 ohm. So 1 by 40, 0.025. Now moving on to G12 or G21, 1 and 2, no resistance is connected between them. So 0. 1 and 3, no resistance is connected between them. So again a 0. 2 and 3 or 3 and 2, no resistance is connected between them. So again a 0 here. So now that we are over with the G matrix, we are going to leave the V matrix as it is for now. Moving on to the I matrix here. I11, current source connected with node 1. So I have a 5 ohm here. This 5 arrow head, it moves towards V1. So plus 5. This IS1 also moved towards my V1. So plus IS2. Plus IS1. This IS2, the arrowhead is going away from my node 1. So minus IS2. So next I22, current sources connected with node 2. I have 2 sources. This IS2 is going towards my node 2. So plus IS2. This 4 ampere is coming towards my node 2. So plus 4 plus IS2. Now moving on to I33, which is current source connected with node 3. Again I have 2. 4 ampere is going away. So minus 4. This IS1 is also going away. As you can see, the arrowhead is away from node 3. So minus IS1. So minus 4 minus IS1. So now we are going to substitute these values in the matrix. So now the next step, we had two equations, V2 minus V1 is equal to 60 and V1 minus V3 is equal to 100. If we observe this equation, we have V1 as a common term. So we are going to bring V1 in one particular side and form the equation. So we get V2 is equal to 60 plus V1, V3 is equal to V1 minus 100. So this makes the solving process a bit easier if we bring the term in one place. So now again we substitute this V2 and V3 in the matrix here. So this is what we get, the final matrix. Now moving on to the next step, we are going to solve the equations and find the voltage and current supplied. Power supplied. So we have written all the three equations here from the matrix. Here IS2 gets cancelled out. IS1 gets cancelled out once we add all the above three equations. This 4 and this minus 4 also gets cancelled out. So On my right hand side I have only 5, and these 3 values will be added. Once we solve this, I can see V1 as a common term here, so I get V1 value once I solve it. That is V1 is equal to 39.13 volt. So next, from the previous equation of V2 and V3, by substituting V1 value, I get V2 and V3. V2 as 99.13 volt and V3 as minus 60.87 volt. Now here I have a minus voltage. Now next step, what we are going to do is voltage across 40 ohm resistor. This is where we will see what to do with the minus. Now if you remember, this 40 ohm resistor was connected with node 3. So the voltage across this 40 ohm is going to be V3. But V3 is nothing but minus 30. So what is the reason why we have a minus voltage here? It is because the direction which we assume to be the flow of current is actually the opposite direction of what it should have been. So we are going to change the direction here. So we change the direction here by using a minus V3. So that is now voltage across 40 ohm as minus V3. So both the minus becomes a positive. So voltage across 40 ohm becomes 60.87 volt. So now we have found one part of the problem. The second part is power supplied by a 5 ohm resistance. So power supplied, power have various formulas. Since this power is supplied by a 5 amp source. So 5 amp, in the sense the current value is given. So I am going to use the formula P is equal to V into I. So that is what we are going to use it here. And as you can see here, this 5 amp source is connected to the node V1. So we are going to use V1 value here. V1 into 5, we get 195.65 watts. So with this, we have solved this problem using supernode analysis. Now let us see one more problem using supernode analysis. So the problem here is to find the value of E using node analysis, which will make the voltage across 10 ohm resistance as 0. So here, this is the circuit given. So here I have the first step which we are going to do is to plot the nodes here. So node V1, V2, V3, V4 and a reference node. So in short, we have 4 nodes. That means 4 cross 4 matrix will be used for this particular circuit. And this circuit we have voltage source as well as current source. So definitely we are going to use supernode analysis here. So the next step what we are going to do is, for the voltage source we are going to consider that as short circuited and use the current source here. So here, as we can see, since this 20 volt is connected with node 1, we are going to consider it as IS1. Arrowhead is, the positive is towards V1, so the arrowhead is towards V1. Next, moving on to this voltage source, this 5 volt positive is towards V4, so the arrowhead is towards V4. We name it as IS4. This V3, the positive is away from V3, so the arrowhead is away from V3 and we name it as IS3. So these 3 voltage sources, we have a corresponding current. So the thing given in the problem is to find the value of E using node analysis. So E here is connected across node V3. So once we find voltage V3, that is what is the value of E, and which will make the voltage across 10 ohm resistance as 0. So what is the given value here is, this is the 10 ohm resistance. So the voltage across 10 is V2. So this is the voltage. So V2 is equal to 0. This is what is said in the problem. So we have one value here actually, that V2 is 0, which is going to make our task easier. Again, for this voltage sources, we are going to find the equation. If I consider this 20 volt, it is connected only with V1. So I can simply consider that particular voltage V1 as the positive is towards V1, right? So we are going to consider that as V1 is equal to 20 volt. This is the voltage, right? For V1, only V1 is connected. So V1 is 20 volt. If I consider 5 volt, I have two nodes through which the 5 volt is considered. The positive is towards V4. So V4 minus V2 is equal to 5. V4 minus V2. V2 is nothing but 0, which we have established here. So V4 minus 0 is equal to 5. That is V4 is equal to 5. So we got pretty much all the voltage values. So with this we proceed with the next step, that is matrix formation. So since I said we have 4 node, we will be having 4 cross 4 matrix here. So 4 cross 4 matrix here by using Ohm's law, that is I is equal to V by R is what is used in this matrix formation. We have I matrix, V matrix, and instead of R we have G. Now the remaining, what is G? The remaining term, where did this R went? This 1 by R is nothing but G. The inverse of resistance is nothing but conductance. So that is what we have used here, conductance matrix. Since this is the inverse of resistance, so while calculating the G matrix, the resistance will be not added directly. Instead, we will use 1 by, that is inverse of all the resistance value here. So again, we calculate the G matrix, the I matrix here, I11, I2, and similarly the E matrix here. Once we get the G, I and B matrix, we simply substitute that in the matrix, the elements. Then we move on to the next step, that is to solve the equations. But here, as you can see, this particular last row of the matrix, which shows IS is equal to 0. So if we consider this particular row, 4th row of equation 2. So here we get IS4 is equal to 0. So we have one particular definite value, that is IS4 is equal to 0. Now when we consider second row, here that is minus 1 by 2 into 20 plus 14 by 15 into 0 minus 1 by 3 into minus E plus 0 into 5 is equal to minus second, this is equal to minus IS4. Since we already know IS4 value, we are going to use that and substitute this particular equation here. So as we can see, we have solved the equations further and we get this particular equation. So now we are going to substitute this IS4 is equal to 0. Once we solve this, we get the E value. So this problem, the question asked was to find E, that is the voltage E for the node V3. So using supernode analysis, we get the answer. E is equal to 30 volt. So I hope the supernode analysis concept was very clear to you. Thank you.